Hello everyone, welcome back to ATPeak. My name is Gael.
I'm Alex. We created ATPeak to showcase art and technology at their peak. We in this first series of events, we are showcasing open source AR project and related technologies. We have a mix of speakers from vendors and the open source community and from universities as well. Thank you very much for joining us today, and we are really excited to welcome Dr. Damos Rompapas from South Australia.
Yeah, Dr. Damo has over 18 years of experience in hardware, software, and everything in between. His research career started in 2013. That year, he obtained his bachelor degree at the University of South Australia, and he moved to Japan to get his master's and PhD degree at the Narai Institute of Science and Technology. He graduated in 2019 and he then returned to his hometown of Adelaide. There he founded Brewed Engagement Extended Reality Labs, more commonly called BEER. He is also the sole author of Project Esky, the open source SDK for Project Northstar. Today, Dr. Damo will introduce us to Project Esky and talk about the goals of BEER and future plans for Esky. And I heard there might be even a live coding session at the end. So stay tuned. Dr. Damo, it's your turn.
And I guess usually you do an introduction with a microphone on. Well then, hoi, Dr. Damo here. We're going to be talking a little bit about a few things regarding BEER Labs. And before we get started, let's move over to a little bit of a PowerPoint. So, welcome to BEER Labs. As very nicely introduced, we are a extended reality laboratory first and foremost. And today, basically, we're going to talk about a few things. First, who are we? Then, what do we do? Then, why do we do? And then, how do we do? And finally, I'll go into a little bit about how you can do when it comes to extended reality, in particular with the Project Northstar. So before we get started into all of the fun stuff, first we need to say, who are we? And basically, BEER Labs is an agency of software developers handling things like games and entertainment, XR research and development, and XR and games research. And these are two very different things altogether. Basically, first we'll get into the what do we do? And as I mentioned, we handle two things primarily when it comes to the lower end of our market, which is all about the game development aspect. And from this, we've got two very exciting projects on the line. One of them is a Ned Kelly inspired Metroidvania 2D platformer. And then the second one is Henosis, which is a platform puzzle game adventure where you play as a little blob to move around the landscape and solve the puzzles. Moving a little bit further forward, we also delve into a little bit of game development. And this one is something that I'm more commonly known for because we worked with a whole bunch of undergrad university students who had never touched an AR headset. And together we built what we would like to call Rock-and-Bot Boxing. And the idea behind this was to create a virtual and AR reality boxing experience with two participants standing larger than 2 meters. And by extending our hand tracking volume limited by the Northstar headset using spring attached gloves in order to throw these virtual punches at each other. Moving a little further forward, we also delve quite a lot into the XR research field. So another one of the students that works with me managed to connect up a little robot to the Project Northstar headset using the Esky software we're describing today. And also on top of this, we have Project Aerial, which is BEER Labs' flagship AR headset, which basically, I mean, it needs no introduction. You got my glorious face on there, which it tries to address some of the industrial limitations of the Northstar headset, and that's mainly about the peripheral view being blocked at the sides. By moving the screen display up at the forehead, we're able to free this peripheral vision. We're hoping that this will be a very useful way to bring this into the industry standards while meeting the industry requirements, in particular the ISO safety standards. Now we move on to the why do we do what we do? And basically, I always like to call the vision where my dream is to be able to interact with all of this AR content in front of me, much like this very famous scene in Tony Stark's, Marvel's Iron Man, where Tony Stark is manipulating the content in front of him in order to better understand the task that he's performing. So this is what the vision is for such an AR system, at least in my mind. Now, what everybody always wants is to be able to do this kind of manipulation using fancy AR equipment, or even to the point where old people can work with these devices. So very simplistic UI. Now, during my work with the UniSA, I got to work with the HoloLens too. And unfortunately, the reality of the situation was that I didn't see that this was kind of the right platform for this kind of experience. And mainly this goes into what the pain of working with such AR devices, where we have very high-end and extremely expensive devices that are capable of producing this high quality content. And to be honest, that while they produce the high fidelity, the high quality AR content, they're closed source and they're very expensive and hard to develop for because of the lockdown OS. So when I moved on to cheaper Pastures, I found the Project North Star headset, which at the moment, like you could get for roughly $600 and it can get cheaper or more expensive depending on what kind of hardware you're sticking in the headset. But this was an optical C3 AR display that was extremely high visual quality, but at the time, the software rendering it was of lower fidelity. And that was mainly due to missing a lot of the stuff that's required in an XR system, much more improved in this day and age. However, because it's tethered to a PC, it's significantly easier to develop for. And basically, this leads down to, what is required for an XR system. Now, when we go for a typical XR setup, we have the input and output of the user. So we have some peripheral tracking and some head tracking, and this goes into the software, and then the software sends its render frames over through a temporal reprojection algorithm and undistortion and compositor in order to display the content correctly to the user. Now, the middleware is always the least talked about part of such a software ecosystem. And that's basically saying, hey, look, we don't want to write all of the code from scratch. Let's use something like a game engine in order to handle all of the development for us, or rather the hard stuff like the rendering and the input output. And instead, let the software handle this while we focus on building the UI UX. Now, big part of that ecosystem is OpenXR, the OpenXR standard. And the basic idea is that we don't need to, as the implementer, worry about handling all of this, but rather call a few API calls. And this is why OpenXR is so important, because we can ambiguously develop such systems using a very nice standard, basically. So we can target one platform and hit all of them in retrospect. Then what's out there? So some of the great work that I've seen for Linux folk especially is the Monado OpenXR compositor and runtime. And basically it handles a lot of this stuff for you. So it handles all of the rendering, the composition, the tracking, and the inputs and outputs of all of the hardware. However, runtimes are not enough. Remember, the vision is that we need full interactivity with the content, and usually this is left up to the implementer or software engineers like myself in order to develop this kind of stuff. So moving a bit further, this is where Project Esky comes into play. And really, it's a framework that was capable of this optical undistortion, this temporal reprojection to ensure content is accurately registered, the head post tracking and prediction, all of this calibration that's required, and more importantly, the hand interactions with virtual content, especially considering it's into the mixed reality toolkit, which is what we'll be talking about when it comes to development. And this is, just as a disclaimer, it's Windows only, and technically speaking, it's not a runtime yet. We're still working on it. So it's heavily integrated into the game engine. But what it allows is something quite special. And this is what leads into, how do we do what we do best at Beer Labs? And what we do specifically is the scaffolding training of XR specialists. So we start off with game developers, and then we train them into XR development, especially using the game engines. Then if somebody was was interested in being able to progress this technology further, we go further from XR development into the XR research. Why we're able to do this in such a neat workflow is we focus on rapid development and porting of our experiences. So say we have a client or developer request of us, we start this off with Esky, and just because we're using Project Esky and the MRTK, we're able to write for one device and deploy to all of them, which is really what makes the stuff that we do at Dear Labs very easy and straightforward. So the question then becomes, how can you do what we do? So this is where we're going to go into a little bit of live coding, and I'm going to switch over to our main desktop, and we're going to do a little bit of live coding straight in front of you for all of you lovely people to see. So I'm going to open up my Unity scene, and we're going to see that already I've loaded up Project Esky clone straight from the Git resources. Then when we open up the main scene, we can see within the Unity environment in the scene, we have the typical MRTK examples that's presented with us. So this includes all of the manipulators and all of the manipulatable objects within the environment that comes with the MRTK. Now, I always say we should start off from this scene because it actually has quite a lot of things that you can build your content off of. We're going to look a little bit into how each object works basically through the headset. So I'm going to start off with your basic manipulatable. So we look at the Earth core, for example, and take a look at the game object on the left-hand side. We can see underneath it, through the inspector, we have a basic mesh, we've got a box collider, and we have what we have called the near interaction grabbable and an object manipulator script, and a bunch of constraints that tell the object basically what kind of restriction do we have on rotation and movement. In this case, we don't have many constraints. Instead, we're able to freely manipulate the object. So what this does is this near interaction grabbable allows the MRTK to take the events from the North Star's Leap Motion Tracker, Ultra Leap Tracker, and then pipe this straight into the MRTK to be able to say, hey, look, there's a hand in the scene. Is it near this object? Are we doing a pinch gesture? And if we are doing a pinch gesture, we can manipulate such an object. So I'm just going to go over this a little bit in more detail. So I'll start by running this example. And just to show you what kind of interaction we can get just from this basic object manipulator. So I'll just hit play here. And with any luck, nothing's going to bug out on me. And we can see that after some time initializing, my RGB pass-through on my North Star headset activates. And naturally, something has to go wrong during a live demonstration, but we can see that at least in the virtual environment, my hand is moving around. It's actually being tracked, even if my RGB sensor has decided to crap itself. But more specifically, I'm able to grab this object at the far distance and see as I'm able to reach out and grab onto it. I can freely move the object using a simple pinch gesture, and we'll notice that some objects deactivate and activate whenever I grab it. So just to run that one more time, hopefully without the headset deciding to crap on me during a live presentation. I think we call this the demo effect. So let's try this one more time. Reach out, grab it, pinch it, and then you notice as I let go and I grab the object, some objects are activated and deactivated. Now, I'll explain nicely why this might be the case. We'll take a look at the node IS30 in the inspector, and I'll expand the inspector a little bit further. So every single manipulatable or every callback the MRTK has includes events for when we start manipulating an object or when we let go of an object and stop manipulating it. And these work as what we call unity events. So we're able to add to this event, drag and drop a game object as the target, and then we can see the unity event activating. and allowing us to select which particular component on this Unity game object we want to work with. So for example, we can tell the game object to say that we want to disable this particular game object, so set it to false. We can also do the same thing for when we enter the hovering of the game object. So for example, if I put my hand closer to an object, or if my hand moves away from such an object, we can do similar actions. Now, I'm going to change my import a little bit just to deal with this little nonsense of the tracking camera. And then we're going to create an object from scratch using the object manipulator. So just looking, and if you remember from our examples, we have 2 or 3 things that we need to add to a game object in order to make it workable live. So we're going to first start by creating a cube. So right click, 3D object, we'll create a cube. And then we see we have this massive, gigantic cube in our scene. Now, I don't know about you, but it's probably not the best idea to have a 1 meter by 1 meter cube sitting in front of me. It'd be very hard to manipulate, right? So we're going to change this scaling size to be a little bit more usable. So we're going to change this to a 10 centimeter cube. Now you'll notice I'm saying 10 centimeter, but these object and these numbers are 0.1. That's because Unity deals mostly as a unit in meters, especially when it comes to AR content within the scene. Now, there may be some advanced configurations that change beyond this, but this is the basic idea. 1 unit is 1 meter. So by creating a 0.1 across the scale for the scaling, we create a 10 centimeter by 10 centimeter cube. I'm going to place that in the scene, maybe roughly in front of the piano, so that way I'll be able to see it when I activate when I start running the game. Then you'll notice that, thankfully, Unity has already created, when it created the cube, the box collider. We actually don't need to do anything further here. But to make it MRTK enabled, we need a few things. First, we need a near object interactable. So we're going to grab a near interaction grabbable script. And we're not going to use the handles. We're just going to keep it as it is for this grabbable object. Then we're going to create an object manipulator. Now, this object manipulator handles pretty much everything that we could do when it comes to interacting with these virtual objects. We're able to allow some far manipulation or disable this. So for example, if I'm far away from an object, I can use a cursor emanating from my hand in order to manipulate it. Or I can choose to disable this to prevent far manipulation from occurring, and that requires the user to reach out and grab this object directly. So we also have options for changing the manipulation type, whether it's one-handed or two-handed. We also have one-handed manipulation, so we can rotate the object about a point. And then finally, we have two-handed manipulation types for moving, rotating, and scale. I mentioned that we can enable constraints, and I'll go into a little bit more detail about that in a second, but these prevent the object in moving in particular ways. Now, finally, in the last of the configurations, we have some smoothing, and this basically says when we're grabbing the object, do we want it to, snap directly to the object manipulation points, or do we want it to be smoother towards this target? So if I grab and pinch this object and move it, we're able to smoothly interpolate between it. Now, I'll show the difference in a little bit, but I'll disable them both for now, and then show what happens when we re-enable it. So I should be able to now go ahead and start this scene, hopefully, without any dramas. Now, as I say that, of course, something naturally has to go wrong, doesn't it? Thanks, Unity. Let's go ahead and reopen that project. Now, as I mentioned, it's not entirely in a stable state yet. We're still working on that, getting those little kinks out. Also, probably doesn't help that I'm powering 100 devices off this poor little laptop. Alrighty then, we're back in our scene. Just to re-implement what we've done. Near interaction grabbable and a manipulator. No, we don't want that. Object manipulator, and we should be good to go there. That's a little better. So as you can see, we have our cube. We're able to pinch it, move it, drag it, move it around. Just by adding a couple of scripts. It's pretty simple. Now I'll stop the scene. Adjust the size of this cube and its placement. And then try adding a couple of constraints to it. So I'll just move this around in a little scene, put it in a better place. Save it in case Unity decides to like being stable. And then we're going to add a constraint. So if I go to the constraint manager component attached and manual constraint, and then add a new constraint, what we may want to do, for example, is change the rotation axis that it can rotate around. So by adding this, it adds a script to this particular game object, and we can see already it's got some default values filled in. So for example, we want to change this constraint so that this happens only on near interactions, and then we want it to only rotate on one particular axis. It's pretty simple, straightforward. We should be able to just hit play after saving. Save early, save often. And then I should be able to reach out and grab it. And we'll notice that there should be some constraint on rotation. But no, I guess there's a little bit more effort involved. So as I tick everything in one by one, we can see that particular rotations are locked. So I'm now no longer able to rotate on the x-axis or the z-axis, but only on the y-axis. Yes, that's another nice thing about Unity. You're able to manipulate and change everything live. So that's one part of the components that we can actually build using the framework. So that's pretty much a good chunk of your movements, handing, grabbing, and moving around. So this object manipulator is really key for that one. But what if we wanted to create some buttons? We're going to move this cube to the side. I'm going to take a look at one of these press interactions here. So if we click on one of these objects, we can see that there's a pressable button, and it's a pretty complex setup. Usually I recommend just copying and pasting from the scene, but basically all this entails is that we again have some collider, and then we add some interaction, near interaction grabbable or touchable script, and then we add a interactable, and we can fill this in a little bit later. I'll leave some documentation at the end of the presentation as to the detail in the docs, because if I go into this, we're going to be here all day. But basically, the events are set up so that way we can have some on-click function and then add Unity events into these callbacks. One example of these basic events, we can see that there's an on-click, and then we're able to change, in this case, a color changer script. So we're able to refer to another script in order to do this. What we could do, for example, if I was to add and then select the cube that we have in the scene, we should then be able to change the game object and set active to false. It's quite simple and straightforward. Now, what happens here is that this interactable fires an event to the button helper, and the button helper then on click fires all of the events associated with it. So what should we expect to happen is when we click this little button in the scene, we should see that this cube here disappears. Now, I'm just going to move this a little bit further forward so that way I can actually reach it without leaning over. And then if I hit play, we can see that there's a little space object here. And if I click it, our magic cube disappears. Pretty straightforward, huh? Now, as I said, this is a little bit of a live coding demonstration, but I'm not actually going to be doing any scripting or coding because that's actually good for Unity tutorials. And I highly recommend that you go to learnunity.com if you want to get more familiar with the Unity game engine. So without further ado, I will switch back over to the actual presentation to nicely summarize up what we're doing. And hopefully I can jump straight to the end. So, as I mentioned, there's a few scripts and whatnot that I can leave into the chat window, and I'm sure the fellas at ATPeak would be happy to link it further forward for all of the learning material. There's two things that I recommend. So there's some MRTK tutorials by another YouTuber, and let me pull up his name right now so I can actually tell you who it is. So this guy is actually really good at explaining how the specifics of the MRTK work and how general XR development works. He goes by the name of Dilma Vasilios. I hope I got that name right. I'm likely butchered it. But there's a link in the description for his channel. I highly recommend you go over there and check it out. And then if you want more info about the documentation in the MRTK, there is a link added in below. And that's basically the by and large of it. Welcome to Brewed Engagement Extended Reality Labs. We've talked a little bit about what it is that we do and how one can develop using the Project North Star headset. By the way, that's the cue for the ending of the presentation.
Thank you, Dr. Damo. Sorry, I was typing. So, taking some notes. Yeah, so thank you very much. It was a really interesting. I really love the live coding session. Yeah, I wanted to ask you a couple of questions.
Sure.
Okay, so yeah, a couple of questions, but related to Project Esky itself, right? And then so related to what. So first of all, well, what's the next develop? Well, I think first question would be, what would be the next development that you envision on the project, if any? For sure, there's something.
Right. So as I mentioned, the big limitation for Project Esky right now is its deep integration into a game engine. We're working very hard over at B Labs to separate this, that way it becomes its own runtime, which is extremely important, as I mentioned, to separate the development environment from the XR environment. Then on top of this, we need to catch up to Monado and make this an OpenXR runtime so that we can really deploy to all afterwards.
Okay, awesome. Yeah, that's yeah. Okay, and also I think another questions like would be like if like a student or anyone, I mean like we do this talk series because we want really to help the open source community. I mean to really focus on, I mean in general the community to focus on open source AR XR technologies and trying to gather more people towards it. So if you, and also students as well, that can be like joining and help. Like it's like what do you think would be the skills required or to help you out? Working on Project Esky.
So you're talking working with or working on? Because there's
working on, not working on, no working with, working on. So okay. Helping you out. Yeah.
So working on. So there's basic computer graphics skills is the fundamental requirement. You need to be quite familiar with low-level C++ code or window rendering or graphics shaders and this kind of fun stuff. If you're looking more at developing the high-level API, so what works in the Unity game engine, then I highly recommend that you go through the Unity game engine itself and learn very deeply on how the Unity development cycle works.
Okay, awesome. And okay, yeah, that's and what are the next plans? This is more. What are the next plans for your the? I forgot the name. The the small headset that actually you created at Beer Labs.
So Beer Labs' main primary aim and focus is creating things like Esky, ways to help out the XR community. Secondary to this, we have a few clients that we work with, but for very obvious reasons, I can't go into more detail behind those clients. The basic idea is that we develop XR experiences, so we're training up people that come from primarily game development backgrounds in order to help with the development of these XR experiences. So it's kind of like you come in, you work with us, you learn how to do what we do, and then we send you on your merry way if you want to move on to another company, or if you want to stay with us, we're very welcoming of this. We always have 100,000 projects on the back burner, so if you're interested, come on over and say hi.
Okay. Yeah, I think it's. I mean, was nice to have you here, Dr. Damo. We can conclude the presentation. We do that's yeah. Thank you very much again.
Ciao for now.
Thank you again, Dr. Damo, for the really interesting information that you share with us today. Yeah, if you are interested in any open source and AR technology, meet us here on Tuesday. We have more amazing guests to come. Next week, Adam Ardwood from Ultraleap will be live with us from England. Adam is the XR engineer lead at Ultraleap, where we direct R&D efforts to expand the capabilities of both haptics and hand tracking technology. His presentation will introduce you to the world of hand tracking, along with all the amazing open projects in the space. We would like to thank all our partners for the support this first series of open source talks. If you like more info about ATPeak and the other lineup talk series, visit atpeak.io, and don't miss our upcoming events. Hit the subscribe button and check out the other AR Talk series playlist. Bye. Bye-bye.